All right, welcome back, everybody. Today we are going to work on sixth grade math with a focus on geometry. Okay, so let's see. You know what? Let's just take a look at what we have to deal with. It looks like I got some check boxes to deal with. I see a bunch of calculators. That's awesome. I see the word area, volume, area again with triangles. I have to graph points. Okay, not that bad. Area again. Blah 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 conditions, wrapping paper, and I'm thinking wrapping paper that's on the outside, so that's surface area. Okay, surface area for number 9. So it looks like a lot of the same-ish things going on. I got a rectangular prism, so that's volume. Rubik's cubes, a rectangular prism, again more volume. So now I'm getting my head wrapped around it. Not that bad, and I get to use a calculator. Yay. All right, so let's go ahead and get started with number 1. Given the triangles, or given the triangle with the following coordinates, ABC, enter the length of AC. So now let me think about this. If I only want AC, I don't care about B. I only want to know what the distance is from A to C. So if that's what I want to find out, let me start by plotting the point A. So remember, it is x comma y. So if I start at the origin or in the center, I go to 2 on the x, and then I go up 5, so there's my A. And then for C, I start at the origin, I go to 2 again, and I go down 6, so there is C. So what is that distance? And this is the tricky part, okay? I always tell my students, you are not counting lines, you are counting boxes. All right, so if that's the case, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I got 11 as my side length, okay, because each one will be a unit. All right, enter the area in square inches of the triangle below. And notice we saw a bunch of triangles, so that's a little hint right there, right? In sixth grade, you need to know that the area of a triangle is 1/2 base times height, or some of you guys might have seen it as area as base times height divided by 2. Okay, either one works. I'm going to use the one I have here on the right side. So I have 1/2. What is your base? Your base is usually at the bottom. You get it? So I'm going to say that the 6 is my base and the height is my 8. So that's a 6. My h is an 8. And again, I can use a calculator. That's awesome. So let's bust that out over here. Let's open it up. Always take advantage of that. Let me make this bigger. So I got 1/2. So 1 divided by 2. And notice my Desmos automatically puts it like that. Click on the right side. Then times 6 times 8. So does that look like my expression right there? Yes, it does. So my total is 24. So there we go. Nice. Calculators are awesome here. Okay, number 3. Select whether the given measurements represent volume or area. So let me think about this here. So if I talk about area, that is 2-dimensional. So think about a square, right? A square is length times width. And if I think about volume, volume is 3D because I'm going to start with a square, but I can make it 3D by adding a third dimension where it is length times width, but now it's times height. So can you guess where we're going with this? If volume is 3D, then I'm dealing with an exponent of 3, whereas the area of 2D is an exponent of 2. So let's go back and fill these in correctly. Let's see, feet squared, that's area. M cubed is volume. And then miles cubed is volume. And centimeters squared is area. All right. Enter the area in square meters. And this is why we read this, right? I love that the state does this because it's a little hint. In square meters, meters squared, right? That's how it looks like. So think about, how did I get meters squared? Well, meters squared means meters times meters. So I have to multiply two numbers, and they have to have meters. Do you see those possibilities right there on the triangle? You got three possible choices. I got to multiply two of them. See what a nice hint that is? All right. So the question is, which one is my base and which one is my height? So one of the things, going back with vocab's important, is to understand is that your base is perpendicular to your height. So what does that mean? So if you know perpendicular, it makes 90 degrees. Okay, so can you see that here? Can you tell if I just turn this triangle, this will be my base and that'll be my height? Can you tell that my height is perpendicular to my base right there? All right. So let's go ahead and go back and fill this in. So my area equals 1/2. My base was 6 and my height would be 9. So let's go back to my calculator. Delete those because I already have the 1/2. Multiply times 6, multiply times 9, and I get a total of 27. Now, one of the things you will realize, and I don't know about the keyboard when you have the state exam, it already says in square meters. So I always have a lot of students who are gonna ask me, I can't put meters squared. What happened to it? Well, it already tells you that whatever number you put is already in meters squared. That's the whole hint to it, okay, which is what I like. So you don't have to worry about this, okay? All right, given the parallelogram with the following coordinates, so, okay, 4 points to get a parallelogram, find the length of BC. There's another length question. So can you guess? They might ask you one of these, huh? It's like another one, and we're barely on number 5. So what do I care about? I only care about B and C. So let's see, B is right there, C is right there. Let's go ahead and plot these points. So B, -3, there's -3. And then up 3, so 1, 2, 3, and I end up right there. For C, I go to 6 in the X direction, and then I went up 3 in the Y direction. So there's my C. How far are they apart? So let's count the boxes. I got 1, 2, 3, 4, 5, 6, 7, 8, 9. So the length is 9 units. Okay. Christian plans on reusing one of his opened Amazon packages by wrapping it with gift wrapping paper and setting it as decoration. Okay, cool. Christian calculates that he will need 125 square inches of wrapping paper. All right, so let's see how he got that. Which condition would make his calculations correct? Okay, so if I'm looking at wrapping paper, let's look at the options. He's going to cover the whole box, so that's 6 sides. He's going to cover 4 sides, but not the top and bottom, so that's 4 sides. Christian will cover the 4 sides and the top, so that's 5 sides. And Christian will cover the outside and the inside of the box. So if there's 6 sides on the outside, there's 6 sides on the inside. That's 12 sides to cover. That's a lot of paper. So what he said was that he only needs 125 square inches. So what we got to figure out is, well, okay, well, let's try to figure out how much one of the sides is going to need. So if I want to find the area of a square or rectangle, okay, it's just length times width, right? So the thing that makes this one special is that both the length and the width are the same. It is a 5 by 5, which makes it a square, okay? And because the length, the width, and the height are the same, this is actually a cube. All right, just vocab out there, okay? But I only want one side, so let's see. 5 times 5 is going to give me 25 inches squared. So if he's going to be using 125, how many sides of 25 inches does he need? So let's do one at a time. So let's do 6 sides times 25. So calculator time. Over here, 6 times 25. That's 150. Nope, that's not it. So it can't be that one. What about 4 sides? So 4 times 25. So calculator, 4 times 25. Oop, that's 100. That's not going to work either. And then the next one, we're going to have 5 sides. So 5 sides times 25. Calculator time, 5 times 25. Hey, there we go. So it looks like Christian is going to cover the 4 sides and just the top. So think about that logic. Does that make sense? Well, if he doesn't cover the bottom, are you going to see the bottom, right, of this gift that he's just pretending to wrap, I guess, as decoration? No, right? You don't need to cover the bottom, just the sides and the top. Okay, so yeah, that makes sense. Cool. Let's go to the next one. I got a 2-part question here. So over the years, you have collected many Rubik's Cubes and are doing some spring cleaning, so you buy a container that is shaped like a rectangular prism. Okay, so before I do anything in geometry, I always like to draw what they tell me. And in this case, it's a rectangular prism. So basically like a cereal box, right? Any type of box. Okay, the base. It is 9 by 12. And if you don't know what I mean by the base is like this. It's the bottom, right? And then the height is 21. Now, does that look like it's 21 inches tall? Doesn't make sense, right? Because the 12 looks way bigger. So this was like not to scale. It's just a quick picture I'm drawing, all right? It's the same. It's no different if I did this, right? Something basic. This one looks more like a box. I'm going to do the same idea. It's just you got to practice drawing these rectangular prisms. All right, anyways, what do we need to do? We need to enter the volume. So let's see, do you remember how to find the volume of a rectangular prism? Well, the volume is length times width times height. So this is my length, this is my width, and that is my height. So I just got to multiply the 3 numbers. That's not that bad, right? So 9 times 12 times 21. And this is what I'm saying. Calculator, awesome. So 9 times 12 times 21. Nope, see, there's my first error. Right? You're like, oh my God, that's a huge number. Did I screw something up? Don't just be happy with it, right? Like, you got to think about it. Yes, I messed up, right? There's a human error. So 9 times 12 times 21. I forgot the times. So then that gives me 2268 or 2,268. So notice how they said in cubic inches. Remember what I said earlier? If it's cubic, that means inches cubed. And if it's inches cubed, that means it's inches times inches times inches. Do you see how I multiplied inches times inches times inches? I told you it's a nice clue, right? I got to multiply 3 numbers. All right, so this one is going to be 2268. Not bad. So now enter the number of Rubik's Cubes that can fit in the container if the edges measure 3 inches. So let me see, a Rubik's Cube, I'm going to do my best to draw this. So there's a square, yeah, it kind of looks like that. It's a 3 by 3 by 3. And if I notice something, 3 goes perfectly into that, right? 3 times 3 equals 9. 3 goes perfectly into that one. So 3 times 4 equals 12. And that one is 3 times 7. So what I'm trying to show you is the Rubik's Cubes are going to fit in there perfectly. So one of the things we got to do is figure out, okay, how much volume does this Rubik's Cube hold? So let's find the volume of this Rubik's Cube. So it's a 3 by 3 by 3. 3 times 3 times 3, and I get 27. So if that's how much you're taking up of space, so your good job is to figure out how many of these fit into that space right there. So if you're trying to figure out how much it fits, that's division. So I'm going to go ahead and take 2268 and divide that by 27. So let me see. 2268. Nope, see, got to double check. 2268 divide by 27. And I get 84. So I got 84 Rubik's Cubes that are going to fit in there. Does that make sense? Well, let me see. I could fit 3 across, 4 that way, and 7 tall. And if I take 3 times 4 times 7. Hey, I get the same number. Look at that. Isn't that interesting, right? So I could check my work. All right. Next one. Enter the area of a rhombus. Oh my God. Really? A rhombus? Like, I don't remember what a rhombus is. That's one of those shapes, guys, that you'll have throughout middle school, high school, and you're just like, yeah. Okay, it's not one of the easier ones. But can you see a very awesome pattern with the rhombus? Can you see any consistencies? Anything that is the same? Hint, hint. So can you tell that this rhombus has 4 triangles that are the same size? And I know the area of a triangle. The area of a triangle is 1/2 base times height. So if I just focus on that triangle, this is my base and that is my height, I'm going to get 1/2. My base is 4. My height is 3. Go ahead and put this in here. 1/2. Nope. 1 divided by 2. Let's go to the right to get out of there. Times 4 times 3. So does everything look okay? Yes. So I got 6. So now that tells me that the area of that triangle is 6. Well, guess what the area of the bottom triangle is going to be? 6. What about the one on the bottom left? It's also 6. And then the one on the top left is 6. So then if they're all the same areas, right, I don't have to remember the formula of the rhombus for the area of the rhombus. I just have to remember the area of the triangle, which is really nice. And then realize, oh, it's just 6 times 4, which equals 24. So not that horrible if we just break it apart, okay? They're going to give us nice clues to make things easier for us. And by the way, the ones you should know is the area of a triangle, the area of a square, which is basically the area of a rectangle, okay? And that's essentially it, guys, to be honest, okay? Because a lot of the shapes are built from these 3 shapes. Like the next one. Can you tell? Can you see it? So enter the surface area. Okay, so it's what's on the outside. In square meters. So square meters means I'm going to multiply meters times meters. Okay? Of the pyramid below. So can we see visually that this triangle is the same as this triangle, is the same as this triangle, and is the same as this triangle? And then on the inside, we have a rectangle, but this one's a square because my length and width are the same. So if it's the outside for the surface area, well, let's first find the area of the square. Then we're going to add the area of the triangle, but we're going to multiply that times 4. So for the first one, my area equals length times width, which is 2.5 times 2.5. Calculator time, 2.5 times 2.5. And I get the area of the box or the square or the bottom of the pyramid is 6.25. Now the area of a triangle is again 1/2 base times height. And then if I look at this, let me clean this up real quick. My base is the bottom. So my base has to be the same as that one on the bottom of the square. So it's 1/2, 2.5, and my height is 3. So let's look at calculator time. So 1/2, go to the right. So now I multiply 2.5, and then I multiply a 3, and I get a total of 3.75. But here's the kicker. I got 1, 2, 3, 4 triangles. So I'm going to multiply that 375 times 4 because I have 4 triangles. So there's my 3.75 times 4, and I get 15. So guess what I do with these two numbers? My square at the bottom, my 4 sides of triangles, I'm going to add those. So 15 plus 6.25. and I get a grand total of 21.25 square meters. Okay. Number 10, enter the volume of the prism in square inches. Okay. So, calculators are awesome. So the thing is, do you know how to write fractions, right? Like, see how it gets crazy with these fractions? So let's see what we're going to do here. Remember that the volume is just length times width times height, which is my L, my W, and my H. I just got to multiply the three numbers, okay? So I got 12 and a half times 4 and a half times 8 and a half. So let's see. I got 12. Then I'm going to press the fraction button. And I'm going to put a 1, go to the right. Nope. See, I'm trying to find it. Where is it? There it is. Okay, there's my half. Now I got to get out of there. I got to multiply that times 4, then press the fraction button, and I got a 1 half. So does it look the same so far? Yes, it does. Okay, so let me get out of the fraction. So now I have another times, and I have an 8, and the 8 has a fraction. So there's a 1 and a 2. So before I do anything, I want to make sure, does this look like that? So 12 and a half times 4 and a half times 8 and a half. Yes, it does. So then my total is going to be 478.125 cubic inches. Okay, is there another way to do this? So this is where you, if you want to be clever, right, and you have gotten good at fractions, because we tend to see the same type of fractions, here's a little mini lesson for us. If I do 1/2, that's 0.5. And if you don't know, guess what? You can literally check, right? Like, oh, I have a half, so 1 divided by 2, oh, sorry, clear that. 1 divided by 2, oh, pues. 1 divided by 2, hey, there it is, 0.5. 1 divided by 3, so let's clear that. 1 divided by 3 is 0.33333333. That's why we put a little line on top. 1 divided by 4 is 0.25. And the last one we really need is 1 divided by 5. So 1 divided by 5, which is 0.2. The reason I say that is because those are the most common ones, okay? So if I see a half and you don't want to write a fraction, we can change it to a decimal. There's a little trick to this. So instead of putting 12 and a half, I'm going to say 12.5. Instead of saying times 4 and a half, it's 4.5 times 8.5. And what answer did we get? It's exactly the same. So that's where, converting into decimals can make things easier on a calculator sometimes. Just a little hint. And again, it takes practice. That's why you're watching this video. Hopefully you're taking advantage of some of these hints I'm giving you, okay? All right, next one. Below is an image of an unassembled box. Edgar is using wrapping paper, otra vez, okay? It's like Christmas. Somebody wrote this during Christmas. To cover the box once assembled, what is the surface area of the assembled box in square inches? So if I look at the box, it looks like I have the same units, okay? So if this is 3, guess what? That's 3, that's 3, that's 3, and that's 3. So if that one is 6 right here, then this is 6. And if this is 6, then the opposite side is 6. If this is 6, this is 6, and that'll be 6. And you get where I'm going with this. So that one is 6, 6, 6, 6, 6, 6, and 6. So what do I care? Because essentially, I am finding the surface area. Can you tell that I basically have two shapes? I have a rectangle that looks like that, and it looks like it's a 3x6. Plus, I have what looks like a square that is a 6x6. So, if I want the surface area, well, let's just find the surface area of each one and then just add them up. So remember that the area is just length times width, which is 6 times 3, which is 18. I'm going to double check. 6 times 3. Yes, it's 18. On the other side, I got area is length times width, which is 6 times 6, and that should be 36. Let me confirm. Not 6 times 3. Delete. 6 times 6. Yes, 36. Are you thinking something? Did you see that I forgot something? What did I forget? Or what did you forget in case we both forgot it at the same time? I have 1, 2, 3, 4 of those rectangular shapes. So I need to multiply this times 4. So 18 times 4, and that gives me 72. And for my squares, it looks like I have 1 and 2. So I need to multiply this times 2. So 36 times 2, and I get 72. So then what do we do with those numbers now, guys? What do you think? So in this case, we have to, hopefully you realize, we have to just add them, okay? So 72 plus 72, and I get 144 square inches. So let's see the second part. Once the box is assembled, Edgar decides to put ribbon along the edges of the box. How many feet? Okay, feet, okay, of ribbon, that should be of ribbon, does he need? So this is where it gets tricky with geometry, like I said, and just having students do geometry. One of the toughest parts is visualization, right? Can you basically assemble this box? Okay, so let me try it. I know the box has a square, right? Can you see that? I'm doing this one right here. If I fold it, and when I say that's the front, then can you tell that this is the back? So where it's in the middle is right here. This is the sides. So there it is right there. Can you tell? So if you're a little lost, can you see that this is basically this and the bottom and the left? Can you see that? The sides. And then the front is right there. And can you tell that the back is right there? Can you see it now, hopefully? All right. So if I have this is a nice thing about technology here. If I have this, I want to do all of the edges. So if I have the edges, I want to know what that one, and that one are. So that one is going to be 6, 6, 6, and 6, right? But those edges should hopefully be the same as these edges right here. So if I have those, I got 6 times 4, right? 6 plus 6 plus 6 plus 6. That's 24. Those are the edges on the front, and I also have the edges on the back, so that's another 24. That's the back. So that's a total of 48. Let me just double check. 24 plus 24. Yes, 48. What other edges am I missing? Well, now I have to do that edge, that edge, that edge, and that edge. So this is where I have 3, 3, 3, and 3. So if I have 3 times 4, that gives me 12. So if I have 12, I can now combine these two and say 48 plus 12, and I get 60. Let me confirm that. 48 plus 12, 60. And notice, again, strategy. I'm doing my mental math as a teacher, and yes, I'm pretty good at it. But every now and then, we all make mistakes, so it's nice to double check. It's the same thing with you guys. Use the calculator, okay? Now, here's the problem. A lot of times, because I did this the first time, I did it wrong. I put 60. Notice what I did. I put it in bold and underlined it and italicized it because you have to put it in feet. So one of the things you should know is this is 60 inches. You should know that 12 inches equals 1 foot. So in other words, I have to say how many 60 inches equals. So if you think about it, I got to take 60 inches and divide it by 12. So if I take 60 inches and divide it by 12 inches, I should get 5. Let me see. 60 divided by 12, and I get 5 feet. All right. That was a crazy one, right? That was a little tough. All right. Enter the volume of the prism below. Otra vez. Okay. So this one, right, you guys have probably seen this one a lot as the area. And usually the area, you split it, right? You could do like that, 2 rectangles, or 2 rectangles that way. Well, guess what? I'm going to do something very similar to my volume. So in this case, what I'm thinking is I'm going to cut it this way and then straight down. So can you tell that for this one, I have 1 rectangular prism? So I'm going to try my best to copy it. So what are the dimensions for the volume? Volume equals length times width times height. So length, width, and height. Well, my length is 2.5. Notice what I did. I changed the 1/2, right? 1/2, I changed it to 0.5. Then my width is not 12. If this is 6 and the whole thing is 12, how do I find that piece? Well, I'm going to take the whole side, which is 12, and get rid of the 6 right here. Dun, 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 dun. Cross that out because that's 6. And I get 6. So then I get 6 right there. And then the height should be the same as the height of the whole thing, which is an 8. So now can we do the math? Let's hope so. I got volume equals 2.5 times 6 times 8. All right. So what does that give me on my calculator? 2.5 times 6 times 8. Did I write it correctly? Looks like it is 120. Well, that's the first part. Now I got to do the bigger one. Can you see it? So I'm going to draw it again. So it looks like this, and then I go like this, and then I went like that and like that. So there's my length, my width, and my height. What are my numbers? So it looks like that 14.5 goes here, and then it goes down here. So that is 14.5. My width is my side right there. So that's this side. Okay. So that side goes to the opposite and it goes straight down. So that's going to be 6. And my height is the vertical one right here. So that's going to be 8. So the volume equals length times width times height. Or in other words, 14.5 times 6 times 8. Calculator time. 14.5 times 6 times 8. And I get 696. So what do we do? Now we have both of our volumes. And what can we do with those? Now we just got to combine them and then we're done. Okay? So let's see what we have here. We have 120 plus 696, and that gives me 816. Whew, that was crazy. Okay? All right. So let's go ahead and move on to the next one. It looks like we got 2 left. Yay. So enter the area of the trapezoid. Again, do you guys remember what the area of a trapezoid is? It's hard, right? Even for high school kids. But do you see how they split it up for you? In this case, you got two triangles and a rectangle. Really, really nice. So all we got to do is break it up. Okay, one thing at a time. So my triangle looks like this, 8 by 6. Then I have a rectangle. And my rectangle looks like I have a 12 because that's the top. Move it down. That's 6. I'm going to go over here. So it's a 12 by 6. And then I have another triangle where the bottom is 14. And the height should also be 6. So let's go back to basics. Area equals 1/2 base times height. 1/2 8 times 6. And calculator time. So 1 divided by 2. Move to the right. So 1/2 times 8 times 6. That gives me 24. Then my area of the next one is length times width, which is 12 times 6. So 12 times 6. Nope, not 126. 12 times 6 equals 72. And my last one, my area is 1/2 base times height. So 1/2 times my 14 times my 6, and I get 42. So what do we do with all these? This plus this plus this should be my total area. So 24 plus 72 plus 42. And I get 138. Yay. Last one. Ay. Okay. So it's the same thing. Volume. The volume is length times width times height. Because notice, I got to fix this. It is not in square inches. Sorry, it is in cubic inches. All right. So I got to fix that. All right. So why is that important? Because that means if it's cubic inches, it looks like this, inches cubed, which means inches times inches times inches. Do you see that? Inches times inches times inches. Hint, 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 hint. All right. So let's go ahead and write this out. I got a 4 times 15 times 8 3/4. Really? So what can we do? What did I teach you guys earlier? That 3/4, I can just put it in my calculator. So 3 divided by 4, and it's just 0.75. So instead of saying 8 3/4, I'm going to say 8.75. So that makes my life a lot easier on the calculator. 4 times 15 times 8.75. And my total answer is 525. Now I'm going to do it the other way, just so you can see it, so you can practice. So I can say 4 times 15 times 8 3/4, just so we can see we get the same thing. So I got 4 times 15 times 8, and then I got a fraction, 3 and 4. Did I get the same answer? Yes, we did. Okay. So again, just extra little strategies I throw in there for those of you who want to take advantage or pick something new. Okay. All right, guys. So that was geometry. Hopefully you realize, this is a quick recap. Geometry questions are awesome because they let you use a calculator. The other thing you should have realized is your area is important, of a triangle, of a square, of a rectangle. Okay. And then plotting points. So you got to know how to plot points for geometry. Okay, guys. Until next time.